What is going on, wonderful people? It's Medicosis Perfectionalis, where medicine makes perfect sense. Welcome back to my statistics playlist. In previous videos, we talked about sensitivity versus specificity, positive predictive value versus negative predictive value, positive likelihood ratio versus negative likelihood ratio, reliability versus validity, consistency versus accuracy, absolute risk reduction versus relative risk reduction, number needed to treat versus number needed to harm. Today, it's time to talk about incidence versus prevalence, new cases versus all of the cases. Click the like button, click the subscribe button, and let's count the incidence of likes. I have two playlists. One of them is called Statistics, the other is known as Biostatistics. Watch them in order for maximum understanding and retention. Incidence is a rate, prevalence is a rate, and what is a rate as far as epidemiologists are concerned? It's the actual over the potential, actuality over potentiality, actual cases, the number of sick people, over the number of people who might become sick in the future, i.e. they have a potential to contract the disease. Usually, epidemiologists measure in 100,000 persons in a population, but you can measure in 1,000, in 100, in 100,000, in a million. You get to decide. It's all fun and games until we hire someone that cannot do math, and then people start to die. Incidence is a rate and prevalence is a rate. Therefore, the incidence rate is a ratio and prevalence rate is a ratio. We have the actual on top and the potential at the bottom. Let's go. Incidence rate is the number of new cases, that's the numerator, over the number of persons at risk of becoming new cases. The actual over the potential. And then if you want this in 100,000, you multiply by 100,000 or 10 raised to the fifth power. If you want it in 1,000 persons, you multiply by 1,000 or 10 raised to the third. How about prevalence rate? It's the total number of cases over the total number of persons in a population. And if you want in 100,000, you multiply by 10 raised to the fifth. In 1,000, you multiply by 10 raised to the third. In a million, you multiply by 10 raised to the sixth. You get the idea. If you wish to see more videos like this in the future, drop your favorite math emoji in the comments. Mnemonic time. How do you remember incidence versus prevalence? Incidence has an N, so it's the number of new cases over the number of persons who have a potential of becoming new cases in the future or in a certain period of time. How about prevalence? It has AL. Oh, so it's all cases over all of the population. If you wish to download these doozy colorful notes, go to medicosisperfectionalis.com. I help you learn, understand, and pass exams. If you want me to personally tutor you, reach out to me on my website. When I walk down the street, someone asks me, "Hey, are you a teacher?" To which I answer, "Yes, how did you know?" And they answer, "'Cause you got a lot of class." Dear student, get your pencil out because I'm about to take you to class. I want you to draw a box like this, and then we will have an input going into the box. So we call this input. And of course, we have an output coming out of the box, just like this. How about the difference between the two? Well, what came in but did not go out is going to contribute to the pool that's inside this rectangle. This is like your kitchen sink. There is an input, that's the water tap or faucet that brings water into the sink. And then you have a pipe that drains your sink. The input that goes into the sink, this is incidence. Here's a mnemonic. Incidence is an input. That's amazing. But where's the prevalence? Oh, I know, Medicosis. The prevalence is the output. Shut the French toast up. The prevalence is what's in the sink. The output removes from the sink. Here is the bathtub. It's called the epidemiologist's bathtub. Here on this humble channel, I've taught many subjects. I've talked about anatomy, physiology, pharmacology, pathology, toxicology, internal medicine, surgery, obstetrics, gynecology, pediatrics, psychiatry, psychology, biochemistry, general chemistry, organic chemistry, all kinds of chemistry, mathematics and statistics. And I've never heard of a bathtub before, save for epidemiology. You know what that means, right? It means that your average epidemiologist is a dirty, nasty piece of work that neither showers nor bathes. And that's why they had to draw a bathtub in the textbook, just as a reminder to boost personal hygiene. These people stink. Do not listen to these people, let alone smell them. They smell worse than my cirrhosis patient with fetor hepaticus. The bar is too low. The bar is on the floor. So what's the input? That's the incident cases, all right? And then what's in the pool, that's the prevalent cases. Oh, all cases, that's the prevalence. And then if this is a deadly disease, some people unfortunately will pass away. And when they pass away, they are removed from the pool of prevalence. But what if the disease is not fatal? Let's say a respiratory illness that you can recover from. Oh, so you can recover and go back, and when you recover, you can become a new cases later in the future. Let's say it's an acute rhinitis. Can you recover from an acute rhinitis? Absolutely. Can you contract acute rhinitis later in the future? Absolutely. And if you do so in the future, you'll become another incident case. So, you can recover and come back as a new case, but once you pass away, you will never come back. What's the difference between incidence rate and attack rate? Both of them are new cases over every person that is at risk of becoming a new case, but there is a difference. Let's continue the definition. In the numerator, we have the number of new cases during a specific period, okay? And in the denominator, it's during that specific period. During that period, but in the attack rate, it's at the beginning of that specific period. That's a big difference. And we will have a practice problem later in this video talking specifically about this issue. Let's practice what we preach. Here are a bunch of questions for you. For each one of these questions, I want you to tell me what happened to the incidence. Did it go up, go down, or stay the same? And what happened to the prevalence? For example, if the mortality rate from a certain condition goes up, what's going to happen to the incidence of that disease? Does it go up, down, or no change? And what happens to the prevalence of that specific disease? Does it increase, decrease, or stay the same? And repeat the same thing with every one of these 10 questions. Pause the video and let me know your answers in the comments. Ready, set, go. Now let me answer them for you. If the mortality rate from tuberculosis goes up, it means that tuberculosis became more deadly. What's going to happen to the number of new cases? Nothing. It does not change. Tuberculosis will become deadly to the people who already have the disease, not to the new cases. So raising the mortality rate or lowering the mortality rate does nothing to the incidence. But does it affect the prevalence? Of course it does. When the disease becomes more deadly, the people are removed from the pool, from the epidemiologist's bathtub. And when the people are removed from the bathtub, the prevalence, i.e. the amount of water remaining in the bathtub, has to decrease. And if I am a lying piece of melana, aka a politician, I can brag about my country or my community. Look, we lowered the prevalence of tuberculosis in this community. Oh yeah, because all of my tuberculosis patients are now dead. There are 3 kinds of lies, said Mark Twain. Lies, damned lies, and goddamn statistics. Never trust a politician, ever. Let's do this. Increase survival time. Now, people with tuberculosis or with cancer live longer after they are diagnosed with cancer. They used to die after 5 years. Now they die after 15 years. What's going to happen to the incidence? Again, nothing. The incidence only cares about new cases, not about the people or the cases that are already sick. What's going to happen to the prevalence as the people live longer? If they live longer, they will remain longer inside the epidemiologist's bathtub. So the prevalence shall go up. And again, if I'm a dishonest sack of human debris known as a politician, I might try to knock out my opponent by saying the following. Look at my opposition. The prevalence of cancer increased in his city or state or country, but the prevalence of the same disease decreased in my country. Yeah, that's not a bad thing necessarily. Maybe the prevalence went up in his city because people are living longer, and the prevalence went down in my city because people are dying earlier. It's all about the context, people. It's all about the context. Hey, Medicosis, do you worry about artificial intelligence? Artificial intelligence, my gluteus maximus. I'm more afraid of natural stupidity. Next, we decrease the risk factors. Let's say that cigarette smoking is a risk factor for lung cancer. Now we have less people smoking cigarettes. What's going to happen to the incidence? The incidence will go down. We'll have less new cases of lung cancer if we have less smokers today. And if there is less incidence, there is less input to the epidemiologist's bathtub, there will be less water in the tub. Next, an extensive vaccination campaign. Let's say we found a vaccine against influenza and it's working. What's going to happen to the incidence of influenza in the community? It decreases and the prevalence decreases as well. There will be less new cases and less total cases. A new effective treatment for tuberculosis was invented. What's going to happen to the incidence of tuberculosis? Remember, there is a difference between treatment and prevention. New effective treatment is going to help the patients who are already sick, but when it comes to the newcomers, no change whatsoever. As for the people who are already sick, they will recover, and when they recover, they are removed from the bathtub, and thus decreased prevalence. Next, we invented a new diagnostic lab test that is more sensitive than before. A more sensitive test by definition is going to catch more people. Let's say we had an old test for diabetes. Now we have a new test that is more sensitive for diabetes. It will catch more people, i.e. it will classify more people as diabetics because it will come out positive in more situations. So the incidence goes up. And of course, when the incidence goes up, the prevalence goes up, all things else being equal. Next, people are recovering faster from tuberculosis. When they recover faster, does that make any difference for the people who will become sick in the future? The answer is no, so there will be no change in the incidence. How about the prevalence? If you recover sooner, you will be removed from the pool sooner, so there will be less total cases. Next, let's say that we isolated tuberculosis patients and we decreased the contact between sick people and healthy people. What's going to happen to the newcomers? The incidence will decrease and the prevalence will decrease as well. Next, we increase the number of deaths from a disease. People are dying. More people are dying. Does that affect the newcomers? The answer is no. When people die more, when more people are dying, more people are removed from the epidemiologist's bathtub and the prevalence decreases. Next, more money from the government for more medical research. Ha 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 ha. When did that solve anything? No change for the incidence and no change for the prevalence. I mean, the last time government grants did anything positive that is, when was the nice Scottish scientist Alexander Fleming got bored in his lab in London, closed the lab, went on vacation, had a great time with the wifey, left his petri dish on the desk, and left the window open. A bunch of fungi, named Penicillium notatum, landed on his petri dish and erased a bunch of bacteria. And voila, penicillin was born. Besides that, government grants didn't do much for medicine. In fact, dreadful wars have done more to medicine than all of the blood money from the government ever did. But don't get me wrong, government grants have been a bonanza. Not for the average man, but for researchers. Researchers got to upgrade their cars, buy better houses, dine in Parisian restaurants. But as for the common man, he continues to suffer, as always. I shouldn't have read Schopenhauer before recording this video. That German philosopher was weaned on a pickle. Here are the answers to all of these questions in a beautiful table that's going to help you a lot in your exam. Make sure to pause and review and practice many times. Question: how many people caught the disease in a specific time? Is this a reference to incidence or a prevalence? Pause and try to answer this. Number 12, how many people actually have the disease right now? Is this incidence or prevalence? Here are the answers. The first one is incidence. The second one is prevalence. Pause and review. Meet Adam, a researcher who uses money from the government to investigate and study acute lymphoblastic leukemia in persons under the age of 20 years. 10,000 persons without ALL are followed from age 12 to age 17. At the end of the study, 100 persons met the criteria of acute lymphoblastic leukemia. What's the annual incidence per 1,000 patient years of ALL during the course of the study? Is it 1, 2, 5, 10, 15, or 20? Why don't you pause the video and try to solve this yourself? Show me. Put me in my place. What do they want? They want the incidence. How do you find the incidence? Remember, it's number of new cases. Over what? Over all the potentials of becoming new cases in the future. Okay, so we're going to say potential new cases in the future. These are people who are not sick today, but they can become sick later. Number of new cases of ALL are 100 persons. You put that in the numerator. Over how many people had the potential of becoming new cases? They were 10,000 persons. So we're going to smash this in the denominator, as you see. Per how many? Per 1,000 patients. You multiply by 1,000, which is 10 raised to the third power. I'm just going to write 1,000. And then you do some simple math. Cancel 3 zeros with 3 zeros. And then cancel this 0 with that 0. Now you have 10. So the average doofus student is going to say, oh, of course this is 10. So the answer is D. No. 10 after I followed these people from age 12 to age 17. This took 5 years. Is that what I want? No, I want the annual incidence per year, not per 5 years. So you divide by the 5 years to get the annual incidence, which will give you 2. So the correct answer is B. That's why you need to get your head out of your sphincter. See, that's what money from the government is going to do to your soul. Especially if you drive a Kia Soul using money from the government. Let me tell you something. If you really drive a Kia Soul, you do not have a soul in you. Get you a Toyota or a Honda or something. So I took the number of new cases, which is 100, over 10,000 persons. And then they want it per 1,000. So I multiplied by 1,000. But don't forget, it took us 5 years. So I divide by 5 to get 2 persons per 1,000 persons per year. That's your incidence, annual incidence that is. Because what's the definition of incidence rates? It's the number of new cases in a specific period. In this case, I want it annually, so 1 year, over the number of persons at risk of becoming new cases during the same period, which is 1 year, not during 5 years. And here is an amazing case for you. 16 professors from ABC University went on a picnic. Because in today's day and age, professors do not teach anymore. They do research using money from the government, or at least they pretend to do research, and they go on picnics. To do what? To contract some staph infections. Haha, get it? Staph infection? Staph infection. Freaking amateur boomers. So medicosis does not let his intrusive thoughts win. But if I did, I will go to the microbiology department of every university. Find the room where the professors' meetings are held. And then at the door, I will find the sign that says staff meeting. So I'll just strike through it and write staff meeting. Or strike the word meeting and write infection. And then I'll wait to see the first professor who laughs. That's the best professor in the department. But I digress. I will not deface public property, which is built using blood money from the government. So we had 16 professors that went on a picnic. Many of them were admitted to the hospital because of staph food poisoning. They probably had some ham, banana pudding, cookies, custard, stuff like that. That's how you get a staph food poisoning. But if you drink homemade carrot juice on a picnic, guess what you get? Botulism. And you would think that these professors would know that, but they don't. Because they spend all of their time figuring out how to use the R in the statistics software instead of reading their textbooks. That's why society is degenerating. But I digress. Here we have patient A, patient B, patient C, patient D, patient E, patient F, patient G, and patient H. You look at this bar for patient A. What does the bar signify? The beginning of the bar is when the professor fuckwits contracted the staph infection. The end of the bar is when Professor Fuckwitz recovered from the staph infection, or from the staph food poisoning to be specific, because this is caused by the toxin, not by the bacterium itself. That's why you do not give antibiotics for such a disease. You just let them recover. Just give them supportive care using money from the government. For patient B, Professor Shitwitz got the disease. here and recovered here in March. And then we'll repeat the same idea for patient C, D, E, F, G, and H. What do you want? I want to calculate the incidence during the blessed month of February. Not in January, not in March, just the incidence in February. Is it going to be A, B, C, D, E, or F? Please pause the video and let me know your answer in the comments. What should we do? Well, I should remind myself of the definition of the incidence. What is an incidence? It's the number of newcomers, new cases, over the number of all the potential new cases, those who are not sick but can become sick during the blessed month of February. So, if you are a DOFA student, you will be tempted to put 16 in the denominator because you will say, oh, the potential number of new cases during the month of February is 16. But that's not correct. If you look closely, Professor Fuckwitz began the disease in January. Oh, so he was not a new case during the month of February because he contracted the disease before February, not during February. So Professor Fuckwitz or patient A does not count. So he's not part of my denominator. So therefore my denominator is 16 minus 1 or 15 instead of 16. There you go. What should I put in the numerator? Every person who started being sick during February. Let's talk about patient B. Did you start in February? Yes, you are part of my numerator. So we're going to call this is 1. How about this patient, patient C? Started in February, so you are with us. How about D? Oh, yep, you are counted with us because you started feeling sick in February. D is also with us. How about F? Started in March, not counted in the numerator. Should I count him in the denominator? Of course, because during this period, he was not sick, but he was potential. He could become sick at any moment in February. That's why he's part of my denominator, but not part of my numerator. How about patient G? Started the sickness in February. All right, so that's with me. How about H? Also with me. So what's my numerator? Here is 1, 2, 3, 4, 5, and 6. My numerator is 6 and my denominator is 15. So the correct answer here is choice F. 6 over 15 is the correct answer. If you got the correct answer, give yourself a pat on the back for me. If you did not, give yourself a kick in the butt for me. You know what? This question should have more accurately said, calculate the attack rate during February. Why? Because the attack rate is the number of new cases during a specific period over number of persons at risk of becoming new cases at the beginning of February, which excludes Professor Fuckwitz from the denominator. But for that previous case, whether it said incidence or calculate the attack rate, it's the same answer. Here's another one. From the table below, here is disease, here is test. These are the people with the disease, these are the people without the disease. These are the people who tested positive, and these are the people who tested negative. We talked about how to construct this 2x2 table in my video titled Epidemiology and Biostatistics, Sensitivity and Specificity, Positive Predictive Value and Negative Predictive Value. You can find this video in my Biostatistics playlist. Anyways, what do you want? I want to calculate the prevalence of the disease. How do I calculate the prevalence of disease from such a table? Of course you can. And if you keep watching, I'll tell you how. Until then, pause the video and let me know your answer in the comments. Quick notes, do you remember my video on study designs, the cohort studies, the case control studies, and the cross-sectional studies? Remember that the cross-sectional studies care only about the present. Do you have the disease right now? Are you exposed to the risk factor right now? What am I trying to calculate? Prevalence. So the cross-sectional studies are concerned with calculating the prevalence. How about the case control studies? No, these care about calculating the odds ratio. How about the prospective cohorts? They care about calculating the relative risk. But if you want the prevalence, you need the cross-sectional study. Because prevalence is what? It's total current cases over total current population. Everything is current in the present, right now. If you watched my video on epidemiology and biostatistics, sensitivity and specificity, I've told you the following, that if you want to calculate prevalence, here's the equation that you use. It's true positive plus false negative over everything. Is that different from the definition or the equation of prevalence that we discussed earlier? No, it's the exact same thing. Let me elaborate. Prevalence is what? It's total cases over total population. And what is total cases? It's the total number of people with the disease. So it's this entire column goes to the numerator divided by total population. And what's the total population? It's the true positive and the false positive and the false negative and the true. All of these people are part of the population. So that's why you put in the denominator, everybody. What did we learn today? We learned that incidence is the number of new cases over the number of persons at risk of becoming new cases. Prevalence is total cases currently over the total population currently. Don't forget to review the epidemiologist bathtub. And please, for the love of God, go take a shower. I can smell the monelia from here. What the hell is monelia? This is boomer talk for Candida albicans. Does candidiasis infection smell? Sometimes it does. But you know what has a more distinct smell? Gardnerella does. It smells like the ocean. Ask me how I know. From reading the textbook, of course. What the hell were you thinking? To learn how to treat Candida and Gardnerella and others, download my antibiotics course at medicosisperfectionalis.com. It will teach you about antibacterials, antivirals, antifungals, and antiparasitic medications. It comes with videos, notes, and cases, and a mind map to help you memorize these medications. Don't forget to take a look at my statistics playlist and my biostatistics playlist. If you value what I do, help me make more videos by supporting the channel. Go to buymeacoffee.com/medicosis. There are more than 750 premium videos available on this channel when you click the join button and choose the highest tier. Please subscribe, hit the bell, smash like, support my channel on Patreon, PayPal, or Venmo. Go to my website to download my courses, notes, and cases, or if you would like me to personally tutor you. Be safe, stay happy, study hard. This is Medicosis Perfectionalis, where medicine, chemistry, math, and physics make perfect sense.